Hi, I'm Kershan Sia, and in my job as a principal systems engineer with a major commercial avionics company, I work with several engineers in different groups, and they come from mechanical engineering, systems and electrical engineering, as well as hardware and software. And we work very closely with our customers to come up with a design for these flight decks that the pilots use so that they can navigate from one airport to another more intuitively. We really build very innovative flight decks for these purposes. So you may ask, how do we design these controls? Well, we have a design process, and we follow this design process to manufacture all our products in the company. So how do we start this design process? Well, it all begins when a designer has an idea for a product, or when a customer comes to us and says, design me this control. Once we understand the problem our component needs to solve, then we have to take into account the special environment in which the pilots will operate the component. Is it big or small? Is it light or dark? For example, pilots must bring all the fuel and oxygen they need for a flight from one airport to another. Also, they must carry equipment to handle emergencies such as fire, engine failure, and loss of cabin pressure. This can make the space in the flight deck really tight. Also, because there might be an emergency in the plane, we have to design our controls to allow the pilots to identify controls by feel if there's smoke or darkness in the cockpit. Each of these constraints have to be taken into account when we design a component. Once we understand the environment, the pilot and other constraints, we then start to brainstorm on how to design the control. Designer starts by using simple materials like clay and the ping pong balls to come up with a rough concept for the control. When the designer is satisfied with the shape, we make a drawing on the computer. Using the computer, we can make changes to the shape and move the controls and switches around easily. Once we have an initial concept drawn up, we can print a three-dimensional copy of the object using a special device called a stereolithography printer. This lets us handle the controller and check out the feel of the knobs, buttons, and trackball. If we want to change their position, it is still easy to do at this pace. Then if we're happy with the locations of those items, we can print another controller and wire in the actual buttons, knobs, and trackball and test it in our lab. This is where I come in. My role is to help out with projects by providing hardware and software which simulate an aircraft flight deck. This allows designers to test out their designs. We call this mockup the Reconfigurable Flight Deck, or RFD. Here, designers can evaluate their projects in a dynamic flight simulation and make sure they work correctly and are easy for the pilots to use. We attach the controller in the RFD in a position as close as possible to the actual location in the aircraft cockpit, and then we use real pilots to test out the component. We test the buttons, knobs, and trackball for reach and response. This testing is important to ensure that the component works correctly. For example, the trackball might be slow, laggy, or too fast. At this point in time, it is still easy to make adjustments to the design. Once the component is successfully passed on the requirements, it is ready for delivery to the client.